Welcome to a lesson with Dr. Powell. Let's take a look at another piecewise defined function. This time, let's take f of x is equal to x plus 2, and then let's do the square root of x. Let's do this for x is bigger than 1, and let's do this one for x is less than or equal to 1. Notice, first of all, that these two domain pieces are disjoint. They don't overlap, which means that this can or has the potential to be a nice function, well-defined, and so in passing the vertical line test. So let's just look at the graph of this thing. So we're going to graph x. We just graph each one of these with the domain restriction right here. So x plus 2, let's think about that as a graph with an x-intercept of 2, slope of 1, but we only draw it for x values that go up to 1. Okay, so we're only going to go up to here, and we include it because it's equal, so we put a closed dot there. And we're only drawing it on this side. We don't draw it on the other side, just on one side, okay, of 1. Now this one right here, we think, okay, the graph of square root of x looks like, it starts like this and goes like this, but we're not going to be including all that, are we? We're not going to include the part that's before 1. So we just start right at 1, except no, it's not equal to 1. So we put an open circle. It needs to be able to pass the vertical line test, remember, even at that closed dot and that open one. Very important to have one closed, one open if you want to pass the vertical line test right there. Okay, and for it to be accurate according to how we wrote it. So, and this is just that part of the square root function, which kind of curves a little bit, but it's kind of softly. So this would be a nice graph of f of x. Now, what if you wanted to plug something into f of x? Suppose you wanted to plug in, say, 4. What would it be? Well, just look at the graph. I mean, so you go to the graph, you go to 4, you go up. It's what function do you plug it into? Well, it looks like we're taking the square root function. So we plug it into that one. So we say 4 into square root would be 2. So f of 4 is 2. Now, another way of doing that is you could just think of this little guy right here as being a filter. So when x comes into the function, the first thing it does is it goes to the filter. And the filter says, which way are we going to send it? Should we send it to this sub-machine or part of the machine or that part of the machine? So the x value 4 comes in and it says, well, less than or equal to 1. Nope, not that one. X greater than 1. Yes, that one. So it'll come into this one, into this part of the machine. So then we have 4 into the square root. It's 2. So let's try another one. What if we did f of 1? So 1 comes into the filter, and the filter says, can't be this one because only greater than 1. Oh, it can be this one. Yep, equal to 1, potentially. So it comes into this one, and then we say 1 plus 2, which would be 3. Another one. What if we did f of negative 3? Okay, which one does it go into? So the negative 3, that is the negative, okay, the negative 3 comes into the filter. And which way does it go? It can't go this way, but it can go this way right here, less than 1. So negative 3 plus 2, that would be negative 1. And we were successful at evaluating the function at a few points. Thanks for watching.